Thank you, everyone. Good morning. So we're going to talk about, oh, wait, because I'm seeing the slides, but it's not being shown here. OK, nice. We're going to do a quick tour about modern Python using FastAPI and friends. So first, who am I? I'm Sebastian Ramirez. I live in Berlin, Germany, but I'm actually from Colombia, South America. That's why the accent. You can find me on the social stuffs. I work for Forethought mainly, which is this company that does machine learning over customer experience data. So integrations with Salesforce and Zendesk and all the stuff. I also work with some other companies, and I created a bunch of open source packages. The thing that is most known will be FastAPI. FastAPI is a Python web API framework that has a bunch of GitHub stars, is used by a bunch of companies. Some people have liked it, so that's cool. That's why they brought me here, because of FastAPI. But now we're going to talk about modern Python. And when I say modern Python, I refer to the currently supported versions of Python. So 3.7 and above. We're going to talk a tiny bit about f-strings, a bunch about type annotations, async and await, performance, community, and all this is going to be through FastAPI, Typer, sqlmodel, and their friends, and like the building blocks that work underneath. So let's start with a tiny bit of f-strings. I hope you are all using f-strings already, but in case you don't, let's just check that. Yeah, nice. So let's say that we have this data structure. This is just a bunch of recipes that we have, and you don't have to check the code. I don't expect you to like read it very fast. And we have a function here that takes a name and a quantity, and it's just going to give us some information about that particular recipe and just return that. That's it. And if we call it with one recipe, then we get the resulting data. We call it with the quantity, and we get a different total. That's all this function does. Now, we can see that we are using a string here, and this string is putting the variable that we took from the function, the parameter name, we are putting it inside. But we are duplicating this information in 3 places. We have name here, and name here. We can refactor that, simplify that just by putting the f here at the beginning, and now we can just include the variable right there. This is an f string. That's all there is to it. It's much simpler, and we reduce the amount of duplication of information. So that's great. And if we call it, it just works the same. If we put a quantity, again, it just works the same. So nice. That's it for f-strings. And now we can have simpler stuff and not all this complexity that we had before, which is very cool. That's it for f-strings. Now let's jump to type annotations, and let's talk a lot about type annotations, or type hints, however you want to call them. So here's the thing. Let's say that when we take the recipe for crunchy frog, we want the result to not include this dash. We want that to be a space. And we want the first letter to be a capital letter so that the message shows more nicely. So we're going to change that string. And then we ask the editor to autocomplete us because we want to change the name string. But then the editor doesn't know what to provide us, what to autocomplete, because the editor doesn't know that this is a string, that what we receive here is a string. And we are fine with that. We have always lived without this autocompletion and these things, but we actually don't have to. So if we just change this tiny bit here, and we tell the editor, and we just tell Python and the tools that, hey, this parameter is actually a string, now suddenly the editor can help us and provide us autocompletion. Whoops. I went, yes, I was able to go back. So this is where we are. The editor, this variable name, and the editor is now able to give us the autocompletion for that because it knows that it is a string. And after we use that, we are replacing the dash with a space. The editor still knows that the result of this is still a string, and the editor and the tools and all that stuff knows that it's a string, so it can keep giving us all this autocompletion. So we just have to add these type annotations in a very few spots, in just very little places, and then we get a lot of support from the editor. And now we can have autocompletion type text for everything, which is super cool. Now, this is what the final result is, and now we can put the title in here. And when we call the function, now we get this nice message here instead of the crunchy dash frog. And well, that's what these type annotations do for us. Now, let's say that we want to refactor this function a bit. Let's say that not everyone really wants a quantity of 1. So let's make, by default, this quantity is going to be none. Seems like a simple thing to change. But then we will run this code. After we run the code, we see that there was an error somewhere. And we have to go and try to see these error messages and try to understand them and see, like, OK, this is pointing to an error somewhere in the code. Where is this file? What is this error? What is this line? What is the problem here? And we have to check that after running the code to see that there was a problem with this. But now, if we add this little type annotation, we change this quantity equals none, and we tell it, hey, quantity is going to be an integer that by default is going to be none. Then now the editor is going to be able to know, hey, this is expected to be an integer, so I expect to be able to work with an integer. But at the same time, this could also be none. So the editor can tell us, there's an error here. And you can see the red squiggly line showing there that there's something funky going there. And if we hover with the pointer in the editor is going to tell us, hey, you're trying to sum something that could be an integer or that could be none. And you cannot sum an integer with none. So the editor is telling us that we have a bug in our code right there, right while we are editing the code before executing it. So the editor and these type hints are helping us prevent a bunch of bugs without us even having to run the code. Before we even save the file, we can have like these errors. Or well, before we commit it to Git, at least. So let's refactor that. We can just move this whole dictionary that we're returning. We can move it outside, and then we can just change it in here. So we just put the quantity, we just put it outside here. And if you see, we are now getting a different error. So what is happening here? The thing is that the editor knows that we are adding some types. So the editor and the tools that we use are an integer. So we can, again, use type annotations to tell the editor, hey, just don't try to be so smart and don't try to infer so much about this data that we are not even defining. And we can just tell it, hey, this is just a dictionary of anything. Don't try to put so much work into telling me exactly what it is. It's just a dictionary. And now with this, we suddenly don't have this little error. So the thing is, you should not add type annotations to everything, not to every variable, just to the things that actually help you be more efficient and detect errors. So you will add the type annotations to, for example, the parameters in the function, or to the things that you need to override and tell it explicitly what it is. To things like that. It's not like we are not adding type annotations to each one of the possible variables that we have. It's just to the specific places that improve the workflow. The other thing is that the editor and the tools are smart enough to know that at this point, quantity can actually be an integer or none. But then, when inside of the code, when you check if quantity is not none, this means that inside of this block, quantity has to be an integer, because we already discarded that it was none. So by this point, it has to be an integer. And the editor and the tools are smart enough to know that by this point, inside of this block, quantity has to be an integer. Quantity is an integer. It's not possible that it's none. So we're going to give all the autocompletion, inline errors, type checks, all that stuff for integers. So we just add some tiny bits of type annotations, and then the tools and the editor and everything helps us a lot. Now, if we want to be a little bit more strict and more formal, we can tell the editor and these tools, hey, this is an integer, but it can actually be also none. This optional is actually not meaning that it's not required. This is meaning this can be none. So this could have been named nonable or something like that. But the thing is that this means this could be none, and that way we can be a bit more explicit about the code. And so with type hints, we can have all that support, inline errors, autocompletion, all the stuff. Without type hints, like, we will have to deal with that. Some of the people behind these type annotations, you can see it's just like normal people that are doing a lot of work so that we can use these things and so that we can work with these things and improve the language. Some of these people are here. Now, let's switch a little bit using type annotations with FastAPI. So here's the thing. We're going to build a web API that does the same thing that we were doing with that function, but we're going to do that with FastAPI. The way that we do it is that we import FastAPI, we create a FastAPI app, and we decorate the same function that we had before. Whenever we get an HTTP GET request that goes to this path and has this path parameter name, FastAPI is going to use this function to handle that request. So we are adding 3 lines of code, and now we have a web API. So the more FastAPI code you write, the less API code you write, because you can focus on your business logic, and FastAPI gets out of the way and does a lot of the stuff just by itself. And you can just like get best practices by default without having to implement that by hand. And of course, we get all the auto-completion, and we can be happy as this cat. And we can get like all the inline errors and all the stuff, because this is just the same type annotations, the same standard type annotations that we were talking about. And because we are using FastAPI, and FastAPI is based on standards, FastAPI also uses these same type annotations to do automatic documentation. If we start the server and we go to /docs, we are going to get an interactive API documentation user interface like this one. And we can see that it's showing those that we have a name that is a string and should go in the path, which is this parameter here inside of the /recipe/ this parameter name. And we also have a quantity query parameter. So this goes in the query, and this has to be an integer. So we have like all the information that we declared in the code, in the type annotations. FastAPI extracts that to give us like the documentation of the API. And if we execute that, this is running in the browser. We execute that request, and this is going to talk to the server that we have running there live while we are editing, and we can get the response right away. So this can help a lot debugging and developing and like iterating quickly. So we write some basic code, and good guy FastAPI builds a docs user interface for you, which is nice. Now, we also get data validation automatically. FastAPI uses these same type annotations to validate the data and to check that the data is correct. So the first thing is that the automatic user interface already does some checks. So we say, whoops, I didn't. Can we go back, please? No, this is running by itself again. What is happening? It's not me. OK, let's see. Let's try again. So we went through all this, FastAPI, all that stuff. OK, let's stay there. Cool. So yes, we made it. Nice. So we have this quantity. This is a query parameter, and it's an integer. If we try to pass a string in there, we say 9. This is a string. This is just text. Then this user interface is going to prevent us from executing that because it knows that this is not an integer. But we can actually cheat. We can just send that through the command line and say, like, we're just going to send it right here. Then FastAPI, that's when FastAPI comes in, it's going to validate the data, and it's going to give us a nice response with the error. And it's just not just telling us, hey, there's an error in the data that you sent. It's telling us exactly where the error is. So it's telling us inside of the query parameters, the parameter query, the value is not a valid integer. So we can know exactly what is wrong with the data that we are sending to the server, and we can fix all those things much faster. So without valid data, this thing moving automatically is just spoiling everything. But yeah, anyway. Without valid data, FastAPI will protect our code from running with erroneous data. But if we have data with the client sends valid data, then everything works as we would have expected with just like the type annotations that we declared in our code. And we also get automatic data conversion. FastAPI converts the data for us when we declare that we need something to be of some type. So if you check these query parameters, these all go in the URL. So this is natively, this is just a string. This is just text. But then we declare that this quantity, which is that thing that we are putting here, that it was an integer. So FastAPI is going to go and convert the value that we pass here. You know, this is just a long string. But FastAPI is going to convert this little thing to an integer so that our code will actually see an integer for that query parameter. And we can see that it works because the total here is indeed an integer in JSON. The other thing is that we can just return a dictionary or return like any object, and FastAPI will make sure to convert it to JSON for the response. So we can just like get this nice JSON. And this is all based on standard Python type hints. And because FastAPI is based on standards, No, standards like OpenAPI, JSON schema, OAuth2, so we can get these automatic docs, API docs like this that we see here. And it's also based on the standard Python type hints or type annotation, so we don't have to learn something new, like, I don't know, FastAPI string or FastAPI integer or something like that. We just use the standard string, the standard integer, standard dictionaries, all those things, and then FastAPI extracts that information for us. And it also does automatic data conversion, data validation, filtering, a bunch of other things, just from the same information of the type annotation. So we don't have to duplicate that information about our data. Now, let's switch gears. And now let's, instead of building a web API, we're going to build a command-line application using type annotations with Typer. So we're going to, instead of importing FastAPI, we're going to import Typer. We create a Typer app, and we decorate the same function. This and this is just the same code we had before, but now we are using Typer. And we are decorating this function with app.command. And then we are, instead of returning a dictionary, because we don't return something on the terminal, we just print stuff. So we are going to just print the result. And now we suddenly just like added some salt, some Typer salt, and we can run this on the command line. And if we, for example, if we call python main.py and we don't pass the name that we declared that was a required parameter, then we have a nice error telling us, hey, you're missing this argument that is required, that is the name. And if we just pass one of the names that are valid, then we just get the message back. And the quantity, which was this same thing that we had annotated as this is an integer, but by default it's none. Now Typer has converted it to an optional command line argument. So we can call dash dash quantity and pass an integer, and now we get the changed result too. So Typer is using these type annotations to give us parameters and options automatically. Now, if we pass invalid data, again, Typer will do the validation of the data. So we can see that quantity 9 is not a valid integer, and this is all done by default automatically just from the type annotations. We also get automatic shell or tab completion when we build an application with Typer. So when you when you build a thing and you have your users install that, they can start typing and hit tab. When they install the autocompletion, they can hit tab, and they will get automatic suggestions of what are the things that they are trying to write. You can check more about all that in the documentation. So now we can build command line interface applications with Typer just by using the same standard type annotations. Now, we can combine Typer with this amazing library called rich for displaying information in the terminal. And we can just sprinkle a little bit of rich information. Here are rich code. And now we suddenly can show very beautiful information on the screen, on the terminal, and display the stuff that we want to show just by adding these tiny bits of like amazing libraries that can work very, very well together. Or like rich is an amazing library that can work very well with Typer. So you can, for example, combine Typer with Rich to build great CLI apps. Some of the people behind these tools, so Typer is built on top of Click. Click is the thing that does all the work behind the scenes. This is the maintainer of Click, and the author of Rich is also here. Now let's switch again to building web APIs. And now we're going to use another cool library that uses these type annotations that is called pydantic. So FastAPI is built on top of pydantic for handling all the data stuff and for Starlet for handling all the web parts. So now we're going to import from pydantic, we're going to import a base model, and we're going to create this class. And we are telling, hey, this class is going to have a name that is a string. And this doesn't have any default value, so this is going to be required. And we also have ingredients, which is a list of strings. Again, this is a standard type annotations from Python. This from typing import list, this is part of the standard Python library. It's not something that we have to install additional to Python or something like that. And we are saying, hey, ingredients is a list of strings that by default is just an empty list. Because this has a default, this means that ingredients is not required. Now, the next thing that we do is that we use that class in the function that we are declaring here. So we are saying that we are going to receive a post HTTP request that goes to /food/, and then we are going to receive this parameter food, and this is the way that in Python, this is the standard way to say, hey, this food is going to be an instance of this class food. So this doesn't mean that food is going to be the class itself. It means that food is going to be an instance of the class food. This is, again, just a standard Python. And we can use the attributes of this object food inside of here, just using dot and just like we do with the standard classes. And now with that information, FastAPI extracts that information from Pydantic, and we can get documentation of what is the data that we expect. So we can see that we expect to have a name that is a string, and ingredients, which is a list of strings. And this is just generated automatically. The good thing, and like the important thing here, is that we are having automatic documentation and validation and all the stuff, not just for the things related to FastAPI, but for the things related to the data in our application, for our business logic, for the things that are important to us. And we can execute that the same way and interact with the server that we have running live. We can just send some data, and we will receive back the response right there from the server when we are coding live with the thing like running on the side. So we don't have to try to send requests through the command line or use Postman or a tool. We can just interact with the automatic API documentation. What happens if we send invalid data? So for example, here, this is JSON. This is valid JSON. Name is a string. Ingredients is a list. This is fine. Albatross is a string. But then the next thing, this is not a string. This is a JSON object or a Python dictionary. Then if we try to execute that, FastAPI will validate that using Pydantic, and we will get the error telling us exactly where the problem is. So inside of the body, in the ingredients, the index 1, a string type, was expected, and we actually received something was not a string. So we get the errors that are telling us exactly where inside of the data that we are sending, where we have the errors. Now, what if we want to have more information on the same request? We want to have a list of these food items. Then we can just iterate for each one of those orders. We just use the standard type annotations again. Now, if we want to have JSON and we want to have it inside of JSON, you can just do that. We can declare arbitrarily complex nested data structures. I know that sounds fancy, but it's just like, you know, you can put things inside of things, and you can just declare that with standard type annotations and like have all the complexity that you need in your data defined with type annotations. And of course, because this is all based on type annotations, see that we are in a double nested for loop, and we still get auto-completion for all the internal parts and all the internal pieces in our own data. And we also, well, we have auto-completion everywhere, which is what I have been building these things for, to get auto-completion everywhere because I have terrible memory. And we also get these inline errors that tell us, like, what is the problem? Again, this is a double nested for loop, and the thing still knows that this is a string and that this is an integer and that we cannot just sum these two things together before we send that to the server live, before we see the code live running. Some of the people behind these things, FastAPI is built on top of Pydantic and Starlet, and another notorious contributor here. Now, let's use FastAPI with sqlmodel. sqlmodel is a library for interacting with SQL databases that is built on top of Pydantic and sqlAlchemy. So we can just declare, the same way that we were declaring the food item before, we can declare this thing, and this is going to be at the same time a Pydantic model and a sqlAlchemy model. So this thing here is declaring that we have a name that is going to be received as JSON data, but this is at the same time declaring that we will have in the database a column that is of type string and that is not non-nullable. This one will be nullable. And now we can use that same model in the same places that we will use a Pydantic model in FastAPI. For example, we can say we're going to have a response model that is hero. We can have that as the input, and we can use that to interact with the database directly, and we can return that object directly. So we can have, and the same way we can also say, like, oh, we're going to return a list of heroes, a list of rows from the database. And this is, again, just using like these same things from the standard type annotations and just interacting directly with the same objects. And because we are using sqlmodel, which is at the same time Pydantic and sqlAlchemy, FastAPI can extract the information of what is the expected type of data that we want to receive or the data that we want to send back. So now we can have database and data models without duplication of all that information, without saying, this is a string here, but this is also a string in the database. Some of the people behind these things, Samuel Colvin, the creator of Pydantic, and Michael Bayer, the creator of sqlAlchemy, because these are the things that do all the work for sqlmodel behind the scenes. sqlmodel just does a lot of black magic to make them work together and be the same thing at the same time. Now, a little bit of modern Python with async and await. So here's the thing. Python is a very fast programming language when you compare it to the network. So the thing is that the client sends a request, it's very slow, it executes quite quickly when you compare it to the network, and it goes back very slowly. So the first idea will be, okay, let's have multiple clients at the same time so they can share all that weight together. And it's a great idea. But the thing is that this is not how it works. It works more or less like this. We have one person in line waiting for this person at the front to try to find the coins to pay something. And at the same time, the other are just waiting. So what if we could, this is how this will actually look like. We have a client, sends a slow request, Python executes, sends a slow response back. This is just because of the network. This has nothing to do with Python. It's just cables are slow. But then the other clients are just waiting in line to communicate with this Python backend. This is how it will work behind the scenes, more or less. And your API app is just waiting for the response and for the network. Now, what if we could have a waiter that goes to each one of the tables and asks them, what do you want? Here's the menu. While you check, I'm going to go ask the others. So this is what Async and Await give us. It's something like a waiter so that you can have your app. Your app will be the code that will be kind of the kitchen, always preparing dishes and always working, never waiting, never stopping. But then you have the waiter that is going and checking each one of the tables. What do you want? Here's the menu. I'm going to wait until you decide what you want. And meanwhile, I'm going to check who else wants something else. Here's the other menu. And then it's going to be able to keep sending orders to the kitchen all the time. That way, the CPU of the server that you are running, that is running your application, is not going to be waiting, idle, doing nothing. It's always going to be working. So you can maximize that and get serve as much users as possible with the same code. This is how it looks in code. So here we're using FastAPI with HTTPX. So FastAPI is underneath an async framework. So you can use async def, and async with, and await. These points where you use await is where you tell Python, hey, this might take a while. You can go and do something else. For this to work, this has to be compatible with await. But this is how the code would look like. It's not that you can just put await anywhere. It has to be in places that support await. But when you do, you get all these benefits. And the web, the communication still works. Sending requests, all that still works the same. But it's just that having this async and await gives us all that throughput, all that concurrency, being able to handle so many users at the same time. And with FastAPI and HTTPX, you can also not use async and await. You can use normal function definitions. FastAPI will do the smart thing that it has to do to not break things. And HTTPX also supports not using that. So you can keep all your current code and use FastAPI, and then you can just optimize the specific paths that need optimizing while keeping the rest of the code that you are already using already working correctly. For those that like the technical details, the thing that FastAPI does is that it will run this function in a thread worker in a thread pool to not block the main event loop. If you don't understand any of that, don't worry. I don't understand it fully either. The thing is that it will do the thing that it has to do to not break things. So now you can use normal def and async def in the same application and combine that together. Some of the people behind these things, Tom Christie keeps popping up, Starlet, HTTPX, and more things. Some of the maintainers and creators of the building blocks for all these things. Now, the performance with FastAPI. This is a benchmark run by Tech Empower, which is a third party running benchmarks for a bunch of different frameworks. Here we are only seeing Golang, which is a compiled language, and Python. Go are the green ones, Python are the blue ones. And as you can see, FastAPI and a bunch of others can get a little bit better performance than some of the Golang frameworks, which is amazing because Go is compiled. And as you can see, FastAPI here has been able to handle 15-something thousand requests per second in this specific benchmark, but that's cool because it's over 9,000, so that's fine. Now, why is it that FastAPI has good performance? FastAPI doesn't have any smart tricks behind the scenes. It just uses great building blocks. So it uses pydantic for data validation, serialization, and documentation, and pydantic is built with Python, which is very fast. Now, pydantic is currently being rewritten in Rust, and it's going to be 10x times faster once that is released. And on the website, FastAPI is built on top of Starlet, which uses the ASCII specification, which is this new thing. And that is run with Ubicorn, which is the server that runs the thing. Ubicorn uses UVLoop, which is a drop-in replacement for async IO that internally uses libUV, which is a library for handling the event loop, and is the same thing that powers Node.js. So the thing is that we are being able to get all the same concurrency and throughput and stuff that we could get in Node.js without having to leave the amazing ecosystem of Python. And yeah, of course, UVLoop is also built with Python. So why FastAPI is fast is just because it's built with great projects behind the scenes. It's just like standing in the shoulders of giants. Some of the people behind these things: Tom Christie again, the creator of Ubicorn, Starlet, HTTPX, Django REST framework, and a bunch of other things. Yuri Silvanov, creator of Uliloop, also of the async and await keywords in Python, the maintainer of Python. So again, this is just like that there's a bunch of people behind the scenes doing all this work for us. Now, this is my main point. This is all done by normal people. This is all done mostly during our free time and just people trying to help others. It's just a bunch of people trying to help. There's no gigantic corporation behind these things. It's, in most of the cases, it's just like normal people trying to help others. And this is the slide where I cry, and some of you will probably cry as well. The good thing is that you can help too. You can help, for example, translating a page in the documentation, or you can review translations from others, or you can answer questions from others, or you can like help with books and features. But there are many ways that you can help maintain these libraries. You can help with other projects. For most of these projects, there are simple ways that you can help and contribute to the community and to others, and that way you are helping a lot these maintainers. You don't have to be an expert in the internals of Python. There are several here that is like, wow, these guys are so amazing, but like you don't have to be that amazing. You can be like me and just like mumble and copy paste from Stack Overflow, but still help a lot of people and help a lot just by helping others. You are releasing the maintainers from a lot of work and from a lot of effort trying to solve everyone's issues. For example, if you check the documentation and you see that there's a typo, you will always find a typo or something that is incorrectly written. You can just right away fork the project, make a pull request, and fix that. And if you are not sure how to go through that process for the first time, maybe you can check the recording or Marlene's talk from yesterday once that's released, because it's a very, very complete walkthrough to, okay, how do I get involved and start working with these projects? And maybe you won't expect the end of the talk, but that's what I have for you. Thank you very much. I'm not sure if we have time for questions, but I'm going to be sitting in the back around there if any of you wants to talk afterwards. Thank you very much.
Questions? I think maybe we have time for one or two questions at the back there.
AI is still relatively young. I think there's a wide industry use of it. As, for example, seen by this meme, the job post that asked for 4 or 5 years of experience while it was created in 1.5 years. What do you think is the main driver beyond that very high and quick velocity of industry-wide adaptation and use? And what do you think is something that is still holding back the project from being used like in a wider manner by the industry?
So I think one of the things that like has helped the adoption is like just that people use it and like it and suggest it to others, and then like others come and like it and suggest it to others. So people have liked it. I think that's cool. One of the reasons why I think it probably was liked is because I put a huge amount of effort into the developer experience. I really wanted, I built it for myself. I have terrible memory, so I wanted to have auto-completion and inline errors for everything. So I built and iterated a lot to just get auto-completion for all this stuff. That involves some code duplication and some extra effort in the maintenance on my side, but that means that when I use it as a user, I get a better experience. And the same with the documentation. I wrote the documentation, and like I have every page of documentation that I write, I end up writing it, refactoring it, rewriting it, and like going through several cycles until I think this is the documentation that I wish I had read when I was just starting. So when I get to that point, that's when I stop. So I try to focus on making it easy for everyone to just like come and learn from scratch. Also, in many cases, explaining like previous concepts, like stuff about APIs or Python in general, like, hey, this syntax might be a little bit weird. This is what this means. I guess that also helps like increase the adoption. Maybe, I don't know.
Friends as well.
There's one over there.
We have one right there.
But I didn't really understand the significance of having auto-completion in doubly nested for loops. Like, why is that significant?
Oh, it's because Because when you have double nested for loops and you are not using something that is based on standard type annotations, it's very difficult that the editor will give you autocompletion. If it was not using standard type annotations, you will probably lose autocompletion at that point. If you had to use, for example, instead of declaring something as this is a string, instead of that, you had to, from super library, import super special string, and then declare that this is of type super special string. Then at some point down the line, you will probably lose autocompletion and those things. The fact that you can declare, hey, this is a list, a standard list of standard strings, that enables the editors and the tools to be able to do all the work they do without having to change things.
Thank you.
Yep.
That's awesome. I think that's probably all the time we have for questions right now. So thank you, Sebastian.
Thank you very much. Thank you.
Let's say.